With every user, there will come a time when you'll need to apply your modifier stack and get to a higher plane of working where you can get back performance when your computer is getting a little bit sluggish, or just apply things because you want to take things in a different direction. Then that's where Smart Apply comes in for you. If we press Q and go under Operations, we can locate Smart Apply under Operations, and by hovering over it we can see the tooltip, which is always your guide to understanding what these tools are doing. The TLDR of this is going to be that if you left click Smart Apply, it's going to apply every modifier except for the last bevel and the last weighted normal, allowing you to work a lot faster and a lot more nimbly without the weight of modifiers holding you down. So anytime you're needing to just apply something and just get forward working while keeping your last bevel live, Smart Apply is there for you. Boxcutter also has a Smart Apply. It's located at the top of the 3D view next to the destructive, non-destructive toggle. Smart Apply is smart in Boxcutter a different type of way than it is in hardops. So we'll just draw a shape, and if we wanted to just apply this, we can just click on Smart Apply and you can see that it applied it and removed the cutter. So we consider that to be rather smart. Another way you can use is we'll draw a box, and if we shift to live, we can keep this shape, and I'll go under my preferences and we'll turn off auto hide and we'll turn on show shape, so that way the next shape that I draw doesn't leave, and we'll just draw this in, and that's where we are so far. But if I select this shape and we choose Smart Apply, we can see that it applied just that shape. So I can select this shape and I can actually choose to Smart Apply just this shape on the mesh, and it will just apply and remove it. However, I'm also able to use Boxcutter in edit mode. And one of the cool things about Boxcutter in edit mode is you're able to hold shift and shift it to live, which will take you into the edit mode of the mesh that you just created. So we'll just modify it by beveling one edge. However, let's say I was done with this cutter and I wanted to apply it. Well, I can click Smart Apply and it will actually apply it and make this back part of the main mesh, where I can then go in and begin making modifications to the mesh. Also got to talk about where the smart part of Smart Apply and Boxcutter ends. So we'll just take this cube, delete it. I'll Shift A, add a plane. I'll press Alt W and switch over to Hops tool. And first we'll choose to bevel vertices, and then we'll give it a little bit of solidification, and we'll adjust the thickness. And from here we'll give it a 2D or a chamfer, and then we'll slap a bevel on it. So now we have a variety of modifiers here. So if I were to switch over to Boxcutter with Alt W and bring this shape down and choose Smart Apply, you'll see that Smart Apply applied the boolean, but since this is a plane, it didn't actually get applied in a way you would think. So if we Control Z and we bring back this cutter, we actually bring it down here where it actually intersects with the original plane. If we select the shape, sometimes selection can be a little tricky, and we choose Smart Apply, you can see that now it actually Smart Applied it, but it actually kept all the other modifiers intact. And this is where Smart Apply in hardops differs. So if I press Control Z, we can bring this back, but the ideal type of apply would be one where it would apply all the modifiers up to the bevel and then apply the cutter. So if we press Q and we go under Smart Apply, we can see that this is the actual idealized version of Smart Apply. So we grab this cutter, we move it up and perform a cut here through our Q menu. If we select Smart Apply, it will just apply it, and we see that it's not going to have that issue. So sometimes the modifiers building up to a boolean can be troublesome when it comes to Smart Apply, but it's because there's a difference between the Smart Applies in Boxcutter and hardops. If we look at this mesh that's in front of me, it's actually built up of a series of meshes. This is actually a curve. This one's actually a curve. This one is a mesh that's mirrored and latticed and bent around. This one is still a curve, and this one is still a curve. However, if I were to want to make everything real in one easy stroke, I would just select everything, get an active selection, and I could actually press Control A and bring up the visual geometry to mesh. However, for this, I probably don't want to be in Boxcutter in order to avoid the deselection of curves. But if I were to press Control A and hover over Visual Geometry to Mesh, you can see that Visual Geometry Mesh is actually convert selected geometry to mesh. So if we select this, we can see that everything has been applied. No ifs, ands, or buts. Every modifier stack has been applied. and this is now a completely real mesh. Another instance worth discussing is what if I were to select all of this geometry and press Ctrl G and make this a new collection and press F9 and bring up the collection box, and we'll just call this solenoid, and we'll just save that. And I were to Shift A, add a collection instance of the solenoid, and we have this in the scene, and we have another one in the scene, and we wanted to both apply and make these real. So the easiest way to do that, in my opinion, would be to press Ctrl A, and we'll choose Make Instances Real, and we see that that actually does not work out. So that is actually the limit of where you can go with certain things when it comes to Blender. However, if we were to select all of this mesh and press Ctrl A, and we chose Visual Geometry to Mesh, it's all been applied, and we could choose Make Instances Real, and we could do the same thing here, Make Instances Real, and now these are real instances of the previous mesh. So I could still go in and do editing to this particular mesh, and it'll still carry over to the main one. So the data is linked in that way, but it's unlinked in the way that it was formerly built up of modifiers. You can't apply modifiers on linked data is the issue. So even converting it to mesh would have been problematic. So I just wanted to talk about using collection instances and converting them into real selections and some of the limitations you can run into with it. One of the more commonly asked questions is, hey, how can I duplicate a mesh and cut on both meshes while cutting on one at the same time, besides mirroring? So if we were to select this mesh and we were to press Ctrl G to make this a group collection, we'll just name this Mike, and we'll just Shift A, insert a collection instance of this, and we'll just put it next to it. And if we select this piece and go to town on it, these changes will of course take place on the other side. I'll just perform a quick box cut, but we see that we're able to work on multiple meshes at the same time, which is basically an easier way to work across meshes that have linked data than dealing with linked duplicates, which can be a little bit limited. So I just wanted to stress on that as well within this video. Csharpen is one of our most classic workflows, but to show it in a nutshell, if I press Q, we can quickly put a bevel on this, and then I will Shift A, add another cube, and we'll just scale this cube up and perform a Boolean operation through our Q menu. Right now, this Boolean is still adjustable. However, this cube doesn't have any of its sharps marked, which is normally the job of Csharpen. However, Csharpen has the ability to apply certain modifiers and then calculate the sharpening. So now we see that the modifier has been applied, the sharpening has been calculated. This actually frees the bowl shape for us to reuse and make another cut again, in which we can then control click to perform a C-sharp. And this is a really classic way of working that I still use all the time when it comes to a kind of touch and go workflow of just cutting in and just making it happen without having to go in and deal with any minor things that could happen. So the benefit of working this way as well is that if you are, say, working in bevel and you press L to switch to weight, this means that we can isolate an area and go in and actually adjust the bevel weight for this area. In fact, we'll bring up the help with H and press Ctrl A, and you can see that I'm able to lower the bevel weight of this particular area, which actually wouldn't be possible unless we were applying these modifiers as we work. So this is basically a destructive workflow that still allows you a small degree of control, and this is what Csharpen was all about. Csharpen is good for applying certain types of modifiers, specifically the bevel and specifically the solidify. Other modifiers can get a little more tricky. So with this cube, we'll delete this point by pressing X and deleting the vertice, and we'll just go under modifiers and just put a solidify to just add a little bit of depth, and we'll put a bevel on it, and then Shift right click to place our cursor here, and we're just going to drop in a cube, and with our cube here we're just going to set up a Boolean. But before that, we're just going to bevel this, press C to clamp, and then roll the wheel to get a nice rounded connection. And then we'll just dissolve one of the edges since they met perfectly in the center. We'll select both of these and perform a difference. So right now this shape is still fairly non-destructive. In fact, to show how non-destructive it is, I can go under operations and modifier scroll, and you can see me scroll through the solidify, then the Boolean, then the bevel. So when it comes to calculating sharpening for this, I can just run Csharpen and it will calculate the sharpening of the cube itself. However, it doesn't calculate anything involving the boundaries, and that's because that information is provided via additional modifiers like the solidify, bevel, and boolean. So this is where Csharpen used to come in and be able to apply. So we'll just bring up our cube menu and just control click sharpen to C#, and we see that it applied it as well as calculated the sharpening based on the 30-degree threshold. And we also see that no bevel was added because that's just not the way that C# rolls anymore. But working this way is good and all, but whenever the meshes get more and more complex, C# tends to break down. But in a general simplified workflow of just working with just very few modifiers, like you can see here, C# is just ace at just being fast, applying the boolean, calculating it, and just letting you continue to work. So maybe at this point you're thinking, hey, C# sounded pretty good. Let's go ahead and make a new file. And we'll just delete this cube and we'll Shift A, add a plane. And I'm going to press Alt W to switch over to boxcutter. And the first thing we're going to do is use a vertex bevel. And we'll just grab that dot and adjust it. And then we'll put a solidification on it. And we'll grab that dot and adjust it. And then we'll choose the second bevel dot, which will add a nice chamfer bevel. And we'll grab that dot and just adjust it. And we'll click on this third dot, which will add a 30-degree bevel. And we'll find that dot and adjust it, just get it just right. And here we can see the modifiers that we have so far on this particular mesh. And so let's say we wanted to double our trouble and make things even more complicated. So let's put an X displace. So we can now grab this dot and move this over. We can actually put a Y displace on this, that's not Y. And we'll grab the Y displace dot and move this over. And now we can press Alt X, and using modifier, we're just going to mirror this across this side, and we'll hold shift when we click this so it stays. And then when we click this side, it will actually just close because we didn't hold shift that time. So now we have two displaces and a mirror going on. So we have quite the modifier stack plethora happening, and quite a more complicated case for Csharpen to handle. So to kind of do an anime flashback, we can hit modifier scroll and we just scroll through our modifier stack just to kind of see how we got to this moment. And it's always fun to just get in here scrolling. But continuing on, so I'm going to shift right click to place my cursor. And since we're in hops tool, I don't have to actually use any hotkeys. So we'll just select both of these and I'll hold control to bring up the hops ring, and we'll just choose cut. And we see that it didn't actually take place, and this is because I cut on the side that we added via the fake mirror. And so we'll just put this on the other side, and I'm going to also alt click sharpen, which will actually add a weighted normal on this mesh. You can also add a weighted normal by going through the modifier, but I added it to sharpen to make things even easier for you. But now that we have all of these modifiers, what do you think will happen whenever I run Csharpen? We'll press Q, and when I control click, I can tell you that holy hell will break loose. And that's because the way that Csharpen is built, it requires that you go in and actually check some boxes that kind of go against the very idea of what Csharpen is intended to do. Like for example, C# should never apply to bevel, but we have it as an option. And we have vertex groups here that you can also choose. You also want to choose to apply mirror. You also want to choose to apply others. And we see that things are still just a little bit out of control here. Let's toggle the bevel, toggle the mirror, and we just see that, you know, this is, I was about to say things look like they're probably not going to work out, but it looks like toggling the vertex group bevels applied only was the trick. So now we actually was able to apply everything that was needed and get this to where we need to get to. But by changing this, we've actually changed the very fabric of what C# is. And me personally, I care about the default behaviors. So me personally, I would rather turn all of these off and not have C# perform any way different than what it's supposed to. So we're back to where we started. And the intended result, just as a spoiler alert, is just going under operations, choosing smart apply, and it will apply everything and leave behind what it's supposed to, basically making for a smarter Csharpen. In the previous section, I showed how smart apply compares to C#, where basically C# requires a bit of rigmarole Smart Apply requires a little bit less. And so, with a mesh like this, let's say I wanted to freeze this at 0 degrees. I could just select this mesh and set it back to 0 and press Control A, and we could just press Visual Geometry to Mesh. And this will actually collapse all of the modifiers, just simplifying everything. In fact, even the weighted normal is applied. So if we just Control A, we can just apply everything. No doubt about it. However, if we were to undo that and say take it to like 190 and we run something like Smart Apply, you'll see that Smart Apply doesn't actually apply the weighted normal. In fact, even in the notification, it tells you that the weighted normal remains, and that's because we will never apply the weighted normal or the last bevel on an object. In this section, I have a little hops room, just kind of tool test. I'll press 1 to go to collection 1, or 2 to go to the collection that has the actual object itself. And we'll select an object and jump over to the modifier stack. You can see that this one has a bevel and a weight as its conclusion. We can see that this one has a weight and a solidify. And all of these are just built in various ways of the C# workflow, of ending with a bevel and a weighted normal, most likely. So what we'll do is just draw a box around this, click to have an active selection, and we'll turn on visibility so you can see what's going on. If I were to press Q and go under Smart Apply, you can see that everything has been Smart Applied. And so if we just click through some of these, you can see that the only things left is the very last bevel and the very last weighted normal. The very last bevel is left because it adds a lot of geometry to the model, which can be a little bit heavy. So we prefer that if users want to apply things just flat out hardcore, you could just use Control A to do that. But for us, we are trying to preserve that last bevel, and that's something that even C# attempts to do. There are some definite advantages to using Smart Apply in such a fashion. I undid back to before I ran Smart Apply, so I'll just select everything and we will just run Smart Apply to just apply everything, and I'll press Control J to just join it all together, and now everything's nicely unified. So with this, I can press Q, go to Mesh Tools, Dice, and we can move the mouse to get a nice dice going, and we will just press T to change the algorithm. Or actually not T, we want to press Q to change the algorithm to mesh intersect, and we'll perform our cut, and it appears that that was a little problematic, so let's try that again. We'll go back and we'll press Q and actually change it to knife project, and we see that that actually went through without any visual issues. So now the next thing is to just rotate this so it's frontal on the x-axis, and we can just take this and use something like twist 360, which will get us a much more interesting result. Since I'm running this all in render mode, and this is a pretty heavy mesh with bevel still live on it, it's going to get a little bit slow, but we'll just dial that back in real quick. But we see that I'm able to turn this into a very interesting twist of a different design. So with a little bit of finessing, I could definitely make this work exactly as I envisioned with the seamless transition. But I just wanted to show how you can use Smart Apply in conjunction with twists to get really interesting designs. Due to the importance of Smart Apply, there's actually too many ways to locate it. So if we select an object, we can press Q, and if we look under Mod Scroll Toggle, you can see that either Alt-clicking this or Control-Shift-clicking this will run Smart Apply. So I'll use Control-Shift-click just in case I was using Emulate Numpad, and we see that we're able to Smart Apply, except this one is kind of a quick Smart Apply, running the utility version, so it doesn't actually display all the information. So we'll select another object, and for this one, we'll locate the Smart Apply located under Operations. So we'll just select that one, and we see that it applied everything, leaving the last bevel and the weighted normal. So we'll select another object, and we see that we have quite a few modifiers here. So if we go under Add Modifier, we see that even Apply Modifiers has the control click behavior, where if you control click it, you can quickly Smart Apply, leaving the last bevel and the last weighted normal. And if we select this bottom piece, we see that we have quite a few modifiers here. But if we go under Mesh Tools, we can see that Smart Apply is here, and we'll just go ahead and click it. And that's just a few ways that you can access Smart Apply. Smart Apply's basic job, plain and simple, is that you should be able to press Q, go under Operations or Mesh Tools, and choose Smart Apply, and it will apply everything and leave behind the last bevel and the last weighted normal. To show it in action again, we press Q, just general click on Smart Apply without holding anything, and we see that it just applies the right modifiers. We'll select this piece, Press Q, go into Operations, click Smart Apply, and we see that it applies it. Even in the multi-use options where you choose it, say, as part of Mod Scroll Toggle, we'll Control-Shift click this, and we see that it just runs general Smart Apply without any of the extra bells and whistles, just vanilla Smart Apply. When using Smart Apply as in the dedicated option, there are additional options that you're able to use. If we took this mesh into local mode, we can see that this mesh is actually comprised of a variety of modifiers. If I were to bring this up and shift click Mod Scroll Toggle to scroll through the mods, you can see that this is built up of a lot of different modifiers. And so if I wanted to grab a specific face of this and make a difference of this, it would actually be quite difficult due to tabbing in edit mode and this mesh not being real. However, if we were to just come out of local mode just real quick and use Smart Apply with the shift click behavior, we can actually do something called Smart Apply Duplicate. So basically this will duplicate the mesh, but actually delete the two modifiers that it would normally keep in the event that they're still there. Otherwise, it would just have no modifiers, allowing you to grab a derived face like you're seeing here. And I'll just inset that, delete the extra mesh, and then just solidify, select both of these, perform a difference, and now I'm able to have performed a derived cut off of a mesh that doesn't actually exist. In fact, I can do the same thing here. I can select this mesh, shift click Smart Apply. I've made a clone. I can't select it very quick, so I will sharpen it, and we'll just select it using that, and I'll just press I and set everything, delete everything else, and we'll just kind of clean things up a little bit because inset can be a little bit rough sometimes. And with this, we'll go under Modifier, hit it with a Solidify, select both of these, difference, and we've done another cut using this derived mesh. And the best part is that we can keep adding on to this based on what's there while still being able to keep adding and dealing with this non-destructively. When it comes to hardops, you can delete a cube and Shift A, add a plane. And with this plane, if we were to just add a bevel, we can see that a 2D bevel was added with the notification as of this version of hardops. We could press Q and go under Operations, and if we were to control click on Smart Apply, we can see that that actually converts this to a curve, allowing you to quickly get this sort of shape. So sometimes I'll actually use this whenever I'm working to just say make a edge bevel, grab this, and now we actually have edit mode where we can convert this into an extraction like so, which is actually a lot easier. So basically, toCurve has taken the place of the control click of Smart Apply, which used to actually convert a mesh into a curve. And I really would only use it in these 2D situations. In fact, we'll delete everything and I'll show you another case in which I would use it, and that would be to create these little hooks. So we'll just delete that, grab these two edges, Control Shift B to bevel, grab these two edges, bevel, we'll put an edge in between, we'll delete vertices to leave it with nothing, and if we were to select this, go under Operations and Control click Smart Apply, we've turned it into this, where it's basically converted it into a curve and jumped us into the Curve Adjust modal. However, I can tell you that we can right click cancel this, go back to right where we started, press Q, and just choose Adjust Curve. And now, actually, no, we don't need Adjust Curve. Let's pretend it was a mesh. So now we are dealing with a mesh. And if we go under Operations and we choose Curve Extract, you can actually just convert it to a curve flat out without any issue. And even press S to shade smooth if needed. Last but not least is Smart Apply's behavior of allowing you to alt click it to perform step. At this time, if we press Control tilde, we can see in the workflow that we're in non-destructive working with angle, and this plays a big role in how step behaves because step behaves completely different when it comes to weight. I'll be going over that in a separate video, but by default, users should be in non-destructive and angle. Let's take this cube and just add a bevel. So we have our first bevel, and let's actually go under Operations and alt click Smart Apply. And we'll see that this actually added a non-destructive step, which is a new bevel at 50% of the previous bevel. And what this means is that if I were to shift right click to place my cursor and Shift A, add a cube, we take this cube and cut it in, we can see that this cube is actually cut in on a whole new level. And this is just a quick way to add extra levels to your bevel in the event that you're working this way. For example, I can go in here, Alt-click Smart Apply again, just completely bypassing step, which is what you should be using in the first place. And we can just go here and just perform another cut, and we see that this is also on another level. So to compare that with step, we can actually go under operations, just click step. It's actually added another bevel. In fact, if we were to bring up our modifier stack, you can see the chain of modifiers that's been built up of us just kind of jumping over our sort, creating new bevels every time, and then putting the boolean on the next level. And to look at this kind of experience in action, we can press Alt W, switch over to hops tool, where if you hold control, you can bring up the hops dots, and we can just drag these to just see each of our bevel levels in action. So while it appears to be very non-destructive, there are some limits to exactly how much you can bend and break all of your previous levels before you begin breaking things that are connected to it. To the uninitiated, Modifier Scroll is located in the Q menu. When you see Mod Scroll toggle, that means that you could shift click in order to bring up Modifier Scroll. You can also go under Operations, where Modifier Scroll is readily available for you to just quickly bring it up. However, I love to bring it up through the shift click of the main menu. When we look at this mesh, we see that there's a bunch of holes cut in that I'm unable to get to because this mesh is non-destructive. If we were to shift click to jump into Mod Scroll toggle, we could actually scroll back to one level before we get to those holes, and by holding shift we can actually perform a Smart Apply duplicate, which gives us this derived mesh. So if I were to take this opportunity to sharpen, because I have seam mark, that means that if I were to go back into edit mode and into face mode, I can actually select this entire face region, press I in order to inset it strongly, press Ctrl I to remove the excess geometry. There will be a few loops in here that will be problematic and have to be removed. In fact, I believe we got it. We could press D, bring up symmetry, and I'll just symmetrize this to the other side to shorten this adventure. And now we have this derived mesh based off of a duplicate, and we were able to generate it from our scroll. So at this point, what I like to do is actually take these meshes, solidify it both ways, and then perform a boolean on the original mesh, kind of giving me this nice little surface inset that I could go back and adjust. So that's one way that you can actually adjust Modifier Scroll with the duplicate behavior of shift. You can scroll to a point in which you want, get the mesh right where you want it, just hold shift, left mouse click, and you will receive a duplicate that's applied exactly at the point in which you were looking at it at that moment in the stack scroll. And this can come in handy for a lot of reasons, but this is the main reason that I use it for, where you're seeing it. Less used but still handy is the ability to go in your Modifier Scroll, where you're seeing here, where I just shift click it from the main menu. We scroll to where we want in the stack, we control click, and we actually apply up to that point, and it turns on the rest of the mod. So now we can actually go in and begin messing with this mesh as if it were a real mesh, because it is. We applied everything up to a certain point in the modifier stack. So this is just an alternative way of approaching the apply workflow inside of hardops. I just wanted to go over it and just show it, just in case this might be something that you want to try in the future, where you want to just apply up to a certain extent through the power of scroll, where you can actually see it on the side just eating these stacks down to exactly where you want it. When it comes to boxcutter, you can start boxcutter by just pressing Alt W, which is my favorite way to start it, and we'll just draw a few cuts here. So 1 cut, 2 cut, 3 cut, 4. So if we wanted to actually apply all of these modifiers, which you can tab in edit mode and see that they're all fake, we can just click this apply button at the top that will smart apply. And what we mean by smart apply in terms of boxcutter is that you can apply, but let's say that you were in edit mode, and you could also cut in edit mode, which is great and all, but let's say that we shifted to live. Now we've shifted to live in the cutter itself. And what this means is that we can go in and do, find edits. I like to grab certain edges and bevel them sometimes, maybe grab the subsequent edges and work them. But if I wanted to apply this and get back to the main shape, I could also click the Smart Apply button in edit mode and will actually switch me back to the main shape, which can be useful. Smart Apply can also go a little bit further. For example, we'll just draw some shapes. We'll press L to keep the shape, but we'll go into our behavior, and in addition to show shape, we also want to turn off auto hide. And this means that now we can just draw a bunch of shapes and they'll no longer be auto hiding. Let's make sure that auto hide is off. There we go. So now we're just stacking these shapes up. And we'll press Alt H to reveal all of the shapes. We can actually select certain shapes and choose Smart Apply, and it will apply just those shapes. And this shape remains live. This shape remains live. And this shape remains live for editing. So in the event that I want to apply this one, I could just click on Smart Apply, that shape's done. I could bring this one down, maybe play with the bevel, press L to change my limit method back to angle. And even if I want to apply this one, just click Smart Apply. If I want to apply them all together, I just click Smart Apply for the main shape, which will also remove the cutter.